Hello everyone, welcome back to my channel, and in this video we are going to learn about AVL rotations. Let's see where we use AVL rotations. When we are having a tree like this is a binary search tree, and if you check balance factor, the balance factor should always lie in the range of +1, 0 and -1. To calculate balance factor, it is nothing but height of left subtree minus height of right subtree. So let's see how do we calculate height of left subtree. From 60, if you want to calculate the height of left subtree, this is the left subtree and the rest over part is the right subtree, if I am right. To calculate its height, we need to see the number of levels it's having. It is having 2. So it is 2. Height of left subtree. Coming to the height of right subtree also has how many levels? 1 and 2. So there are 2 levels. So height of left subtree minus height of right subtree, that is equal to 0. Now this lies in the range of balanced factor. So this 60 is said to be balanced. When we are having something like 22, 30 and 35, if we are having something like this, now if you calculate the balance factor of 22, it is not having left subtree, so it is 0, minus if you calculate its right subtree, how many levels is it having? 1, 2. So it is having 2 levels. 0 minus 2, that is equal to -2. So this is out of range of balance factor. So this node is said to be unbalanced. So now we use the following AVL rotations in order to make the tree balanced. Let's see all the 4 types of cases we are having in AVL rotations and how do we solve those. The first case is left-left rotation. It is also represented as LL. To solve the LL problem, we need to do the right rotation. Right rotation is done at the node which is having the unbalanced factor. So now let's construct a tree and then let's look how we apply this AVL rotations. Okay, the first element is 30, so it would be the root node. 20 would come at its left because it is smaller than 30, and 10 would come at the left side of 20 because it is smaller than 20. So now checking the balance factor, always check the balance factor from the leaf node and go up to the root node. So coming to the leaf node, it is 0. Always remember, every leaf node has a balance factor 0 because it is not having any kind of left subtree or any kind of right subtree. Coming to the middlemost number, that is 20. It is only having the left subtree. There is no right subtree. So it is 1 minus 0, that is equal to 1. Coming to 30, it is having only left subtree and the number of levels are 2. And it is not having right subtree. So it is 2 minus 0, that is equal to 2. Now this value is +2. Okay. Plus indicates that the problem is always on the left hand side. The reason being, the balance factor is nothing but height of left subtree minus height of right subtree. So when would this value be positive? When the left is greater than right. When this value would be negative? When right is greater than left. So now the weightage is on left hand side. So the problem would come at the left side. So let's mark the problem. It has occurred due to insertion of 10. So it is at left, left. Now to solve this following problem, we need to use right rotation. Where do we use right rotation? At the node where we have got the problem, that is 30. So we'll rotate this 30 to right side. So now let's see how this tree becomes. 20 would come at the top, 10 would be at its left, and 30 would be at its right because we are bending it to the right side. Now if you check the balance factor of each node, the leaf node would have 0 and 0. Coming to 20, it is also balanced because height of left subtree is 1 minus height of right subtree is 1. So it is 0. Now this is a balanced tree. Balanced tree. Now coming to the second case. The second case is right rotation. To solve the following right rotation problem, we will do the left rotation. Where do we do it? At the node where we have got the problem. Now let's see how do we solve it. First, let's insert the following numbers. 10 would be the root node. 20 is greater than 10, so it would come at the right side. 30 is greater than 20, so it would come right side of 20. Now checking the balance factor of each node coming from leaf node. So 30 would have 0, 20 would have 0 minus 1 because there is no left tree. So it is minus 1. Coming to 10, it is not having any left subtree. So it is 0 minus, and right side it is having how many levels? 2 levels. So it is 0 minus 2. So that is equal to minus 2. So now to solve this, we need to do left rotation of what? The node we are having problem. So we simply rotate this 10 towards the left side. Let's see what happens. 20 would be as a root now, and 10 would be at its left side and 30 at its right side. Now if you check the balance factor of the following nodes, then 10 and 30 would have 0 0 because they are the leaf nodes. When you come to 20, it is 1 minus 1 equal to 0 because height of left subtree and right subtree both are 1. So now this tree is said to be balanced. How it has become balanced? By using the following AVL rotations. Now coming to the third case, it is left right rotation. See, in all the cases we have seen the single terms like LL or RR. But here we are having two different terms. To solve these different terms, first we need to make it into a single term. Here's a simple logic that you need to remember, that is, the first term here is L. So try to make it as LL. When you know LL, you know how to solve the LL. We have seen in the first case. See, LL can be solved by right rotation. So that's what you need to do. To convert it into LL, you just have to do left rotation. LL means left rotation. Okay. Now first let's insert and then let's see how we solve this problem. 30 would come as the root node. 10 is less than 30, so it would come at the left side. 20 is less than 30 but greater than 10, so it would be at the right side of 10. Now if you check the balanced factor, 20 would be 0 and coming to 10 it is 0 minus 1, so that is minus 1. Coming to 30, it is left side, it is having the two levels. This is the first level, this is the second level, but right side of 30 there is nothing, so it is 2 minus 0, that is equal to 2. Since it is a positive number, we know that the problem is at the left side, so it is L and R. To solve LR, we first need to convert it into LL. How do we convert it? We need to do left rotation of this parent. This is the grandparent and this is the child. So at the parent, we need to apply the LL. That means left rotation. So this would get rotated to the left. So let's see how the diagram is formed. I'll change the color. 1 second. So now 30 would be as it is the grandparent. So doing the left rotation, 10 would come to the left of 20. 20 would come down. So since you are rotating it like this, 20 would come in place of 10 and 10 would be left of 20. Now to solve this LL, now this is in the form of LL. You know how to solve LL, that is right rotation. Where do we do right rotation? At the node where we have got this problem. This is the node, right? Here we have got that plus 2. So we'll rotate this node to the right side. So now 20, left side of 20, 10 as it is. Now 30 would come at the right of 20. Now if you check the balance factor of each node, 10 and 30 are balanced again. The reason being they are leaf nodes. Now if you take 20, it is also balanced since height of left subtree is 1, height of right subtree is also 1 and it is 0. So now this is said to be balanced tree. Now coming to the case 4, right left rotation. The same thing I would say. You can't directly solve RL problem. So here also you take the first term. It's right. So you need to first convert it into a single term. That means you need to convert it into RR. After converting it into RR, you know how to solve the RR problem. You just have to do the left rotation. That's it. Now let's see how we apply it in the problem. That would give you a clarity. So let me change the color again. 10 is the root node again. 30, it is greater than 10, so it would obviously be on the right side of 10. Coming to 20, it is greater than 30. It is greater than 10, but it is less than 30, so it would come at left side of 30. Checking the balance factor from the leaf node, 20 will have 0, 30 will have 1 because there is only left node, and coming to 10, it is 0 minus 2 because there's no left subtree. It is only having right subtree and it is having 2 levels. See, this is the first level, this is the second level. So it is minus 2. Now we have to turn it into RR. Where do we do RR? At parent again. See, this is the child, this is the parent, and this is the grandparent. At parent, we'll do the right rotation. RR is nothing but doing the right rotation. Right rotation. Okay. So, doing the right rotation is nothing but we'll rotate this thing. We'll rotate 30 to the right side of 20. So, solving it, 10 would be as it is. Now, 20 would come at the top and 30 would be at its right. Okay, now it is in the form of RR. So to solve this RR, what we do? We do the left rotation. Where do we do the left rotation? At the node where we have got the problem. So now we rotate 10 to the left side. So now 20 would be as a root, 10 would come at its left and 30 would come at its right. So if you check the balance factor of this tree, then 10 and 30 would have 0 and 0 and 20 would have 1 minus 1, that is equal to 0. So this tree is now said to be balanced. So now the AVL rotations basically are used to balance every single node in a tree. Now let's see a simple problem so that you'll have clarity on how to apply them when they come to the application part. The following question says to insert the following elements. So let's see. 30 would come as root node. The insertion takes place as the rules of BST, like the greater element from root is on the right side and the smaller element would be on the left side. The only thing here you need to see is, since it is an AVL problem, you need to check the balance factor after inserting every single node. Okay, 30. 30 is done. 20 is smaller than 30, so it would come at left side of 30, so that is 20. Now the next you need to see is balance factor. It is having 0 since it's a leaf node. 30 is also balanced because there is only one left subtree. And coming to 10. 10 is smaller than 30, smaller than 20. Now if you check the balance factor, 10 is having 0, 20 is having 1 minus 0, that is equal to 1. But coming to 30, it is having 2 minus 0, that is equal to 2. Now here the problem arises. How has the problem come? Due to addition of 10 at the left side of 20. So it is due to L. To solve the LL problem, what we need to do? We need to do right rotation at the node where we have got the problem. So we'll rotate 30 to right side. So 20 would become the root node now. 10 would be at its left as it was before, and 30 would come at the right side of 20. Now checking the balance factor, 10 is having 0, 30 is also having 0 because they are the leaf nodes. Coming to 20, it is having 1 minus 1, that is equal to 0. So everything is balanced. Now coming to 40. 40 is greater than 20 and greater than 30. Now if you check the balance factor, then the leaf nodes 40 and 10 would have 0 and 0. Coming to 30, it would have 0 minus 1, that is equal to minus 1 because there is only right subtree. Coming to 20, it is having 1 minus 2, that is equal to minus 1. So everything is balanced. Coming to 50. 50 is also greater than 20, greater than 30 and also greater than 40. So 50 is added over here. Now again if you check the balance factor, now let me change the color. 50 is having 0, 10 is also having 0. Coming to 40, it is having left is 0 and right is minus 1. So it is minus 1. 30 is having 0 minus 2. So it is minus 2. Here we have got the problem. Now if you check for 20, it is 1 minus 3. So it is also having minus 2. Now there are two problems in this question. So which to solve first? The problem which comes first, like we are going like this from leaf node to the above. So the first problem where we are getting at 30. So first we try to solve this thing. Now why has it occurred? Because we have inserted the element 50. So where is 50? At right. So it is the RR problem. How do we solve the RR problem? We do the left rotation. At where? At the node where we have got the problem. So we rotate 30 to the left side. So what would happen? 40 would get attached over here, and let's see how it happens. So 20 would be as it is, 10, and now rotating 30 towards the left side, 40 would get attached to 20, and 30 would be at the left side of 40 and 50 at the right side of 40. Okay, now if you check the balance factor from down, again 0 0 and 0 for the leaf nodes. 40 is also balanced because it is 1 minus 1, that is equal to 0. And coming to 20, it is 1 minus 2 levels. This is the first level, this is the second level. So 1 minus 2, that is equal to minus 1. So if you have solved one problem, the other problem already have got solved. So there is no need to solve it again. So now it's balanced. Now the next element to insert is 25. Now where do we insert 25? It is greater than 20, less than 40 and also less than 30. So it would come over here. Now we should check the balance factor of the following three again. So 25 would be 0, 50 would also be 0 and 10 would also be 0 because they are the leaf nodes. Coming to 30, left side it is having 1. So it is 1 minus 0, that is equal to 1. Coming to 40, it is having 2 minus 1. So that is equal to 0. Coming to 20, it is having 1 minus. Right side, it is having how many levels? This is the first level, this is the second level, and this is the third level. So it is 1 minus 3, that is equal to minus 2. So now here we have got a problem. Okay. To solve this problem, what we need to do is, so now the problem has occurred because of 25. So it has because of right, left. So to solve RL problem, I have already said that we need to convert it into RR first. That means now this is the child, this is the parent, and this is the grandparent. So we need to rotate the parent to the right side. Okay. So rotating it towards the right, let me take another color. So this would become 20 as it is, 10 at its left. And coming to the next part, since we are rotating it, 30 would come at the top, 25 is at left of 30 as it is, 30 would be right of, 40 would be at the right side of 30 and 50 is at right side of 40. The first part is completed. But the problem has occurred at the 20. So since it is in the form of RR, now we need to do left rotation. Left rotation at the node where we have got problem, that is at 20. At 20 we'll make a left rotation. So let's see what happens. Now 30 would be at the top and right side of 30 we are having 40, right side of 40 it is 50, and left side of 30 20 would come, left side of 20 10 would come, and this 25 it would come and join here, because at the end it has to satisfy the BST properties. So now again checking the balance factor of each node, all the leaf nodes would get 0 0, and coming to 40 it is left minus right, so it is 0 minus 1, that is equal to minus 1. At 20 it is 1 minus 1, that is equal to 0. At 30 it is having 1 2 levels, and right side also 2 levels, so it is 2 minus 2, that is equal to 0. So now the tree is balanced. Now let's see what we need to insert the next. It is 45. So inserting 45, it is greater than 30, greater than 40, but it is less than 50. So let's insert it. 45. Now check the balance factor of each node again. So all the leaf nodes would get 0 0 0. Coming to 50, it is 1 minus 0, that is equal to 0. Coming to 40, it is 0 minus 2, that is equal to minus 2. Coming to 20, it is 1 minus 1, 0. Coming to 30, it is 2 minus 3, that is equal to minus 1. Now this 40 part is not balanced. So what do we do? It has occurred because of adding 45. So how has it occurred? Right, left. So how do we solve RL problem? We first convert it into RR. Okay, to convert it into RR, we need to rotate this parent part to the right side first. So let's solve it. 30 at its top, 20 as it is, 10 and 25 as it is. Coming to the right side, 40, and we'll rotate it into right side. So 45 would come at the top and 50 would be at the right side of 45, since we are rotating 50 completely. So now after completing, now it is in the form of RR. To solve RR, what do? We'll do the left rotation. So that's what we are going to do now. To do the left rotation at the node we have got the problem. This is the problem. So we'll rotate 40 to the left side. 45 would go and stick to 30. So let's draw it. The left part would be the same. 30, 20, 10 over here, 25 over here. Right side of 30, 45 would get stuck to 30. Left side of 45 will have 40 because we are doing the left rotation, and right side of 45 we are having 50. Now if you check the balance factor, all the leaf nodes would have 0. 45 is 1 minus 1, that is equal to 0. 20 is also having 1 minus 1, that is equal to 0. 30 is having 2 minus 2, that is equal to 0. So the whole tree is balanced. So this is how you use AVL rotations to make the tree balanced. If you are constructing normal binary search tree, then you don't have to follow this rotations. But if you are constructing an AVL tree, then you need to definitely follow these AVL rotations to make the tree balanced, to make every single node balanced. So that's it for this video. Hope this was helpful. Do like, share, and comment your opinions below. And don't forget to subscribe to my channel if you are new. And thanks for watching. See you in the next video. Bye bye.